Welcome. Let us talk about very exciting topic. We call it XML, Extensible Markup Language. And as you understand that markup language is a very common language in the world, and we have the most common one that you are so familiar with is hypertext markup language, HTML. So take a look at this discussion, what we want to discuss about. So far we talked about SQL, views, transaction, conceptual modeling, and we are starting the XML. So data integration is a very important. So in XML, extensible markup language, the most understanding about it is that XML 1.0, it came from World Wide Web Consortium in 1998, quite an old language. The root actually of this particular extensible markup language lies on simple generalized markup language, HTML, a very nasty language. Why? Because it is generalized. But it's actually XML came from HTML, but the entire idea of XML is that we want to represent data on the web. And HTML, hypertext markup language, is to represent information for the presentation. But how do we represent data on the web? That's why XML came up with the concept that you can represent your data for the web using the concept XML. So after the root, a format for sharing data is actually XML. So why XML is of interest? Because it's just syntax for data. We can represent our data on the web, and XML is not relational, so it's semi-structured. And this is exciting because it can translate any data into XML. That means since you are doing advanced database, one of your target is to represent data using XML. You can ship XML over the web. That means you can pass your data using a web, hypertext transfer protocol. You can input XML into an application, and thus data sharing and exchange on the web is one of the phenomena in terms of dealing with XML. Now, happens to be XML, the data sharing and exchange protocol. You can see here that one hand you have XML data. These are actually different applications in the PC. In between you have actually a hypertext transfer protocol. So one area, you see one set of system called legacy, and another set of system is a very modern. The legacy can talk to the modern using the concept of XML because you're exchanging data. For example, your data is in IBM mainframe and you're running a Java application in a very smart PC. How can your Java application read data from the IBM mainframe? If you have XML, the data are converted into XML and Java application is reading XML to run, it's done. So the concept of from HTML to XML, HTML is for presentation, but XML is for the data. So you can see an example HTML file. These are different tags and every tag has its own definition. But when it comes to XML, you can define your own tags. For example, you see bibliography and then you have books and it has a title tag, author tag. You can have multiple author, publisher, year, and end of book. So in XML, you define your own tag based on your data presentation. All right, so XML actually is very flexible, very powerful, and well, of course, there are concepts that how do we know that whether the XML is correct. These are web services, a new paradigm for creating distributed applications, and systems communicate via message contracts. Example like order processing system, you are actually using web services, and XML, a part of the story, the data format. So what are the terminology you have in XML? You have tags like book, title, author. Every tag there is a start tag and an end tag like book and end book. Elements, you have a book and then you have different elements. Elements are nested. You can have empty elements like red, end red, there is nothing in between. And XML document, single root element. That means well-formed XML document, if we say WF XML, well-formed XML, if it has matching tags. That means tag must be matched. That means there is a beginning tag, but somehow the end tag is missing, will not work. A well-formed XML means you have to have a tag must be matched to each other. So XML attributes, you can look here interestingly, book tag, price is 55, price is an attribute, currency is equal to USD, it's actually attribute. But child element of book is title, end title, author, end author. So alternate ways to represent data also through XML attributes. You can have XML OIDs and references. You can see here OIDs and references. For example, you define a person ID. His name is Jan, end name, person. You can refer how. Now, person ID, another person, name is Mary, name, children, but ID ref means you are actually referencing the previous ID. These IDs are actually, they are the children of actually Mary. So you can see that OIDs and references in XML are just syntax, and you can actually use them. You can ID এবং ID ref is indicating one is the ID and another is the reference ID. So XML semantics a tree is very important for you. Why? Because in our discussions, this is something we always try to understand and evaluate. A given XML on the left hand side, you can see, and you design a tree from that XML, starts from the root node to all the leaf, and you see interestingly the intermediate nodes are all actually your elements, and the leaves are actually data items. You can see all leaves are data items. So XML data, XML is self-describing, you can understand, and it has a schema elements become part of the data. There is a relational schema like person, name, phone. That's a relational schema like person, name and phone, but how do you represent in XML? Persons, then a name, phone, these are all become actually are part of the data and are repeated many times because these are all tag, child tags and so on. So what is the consequence? XML is much more flexible. And relational data as XML, you can see here, on one hand we have a table, and then we are actually developing a XML, person, name, row. Each row you can say row, and so on. And then each row you have name and phone number, name, end name, phone, end phone. And ultimately, that means from a given table, you develop XML and then develop the tree. So this is very important that you know how to do this tree. I am going to give you a data table, and from there you form an XML and you define a XML tree. Alright, so XML is semi-structured data. There are missing attributes you can check, could represent in a table format also. Yeah. XML is, you can understand that it's impossible in table in terms of defining, some of the columns are missing. So you can understand that attributes in different types you can have. There are nested attributes into first normal form, heterogeneous collections. This is something very important. When we say document type definition, DTD actually is a document that can validate XML. That means I'm saying that I'm writing an XML, but my XML is representing data, and this data is coming from a data table, but data table has its own definition. So that definition type I can define in actually XML DTD. So it's part of original XML specification. An XML document may have a DTD, may have, you see, it's not mandatory, but when you give a DTD, I can then read DTD and check your XML if it is correct or not. So XML document well formed if tags are correctly closed, valid if it has a DTD and conforms to it. That means if you say well formed XML, this is one definition. Why? Because the XML tags are correctly matched. And when you say valid XML, that means it is based on a DTD. So validation is useful in data exchange. That's why we need to write document type definition. I'm going to show you some. It's a very simple DTD. You see doc type company. DTD always starts with doc type. And the document type, its name company. What you have in this company? Company as an element, and you have a person and many product. You see, many person, many product. What is a person? Person is an element. Person consists of SSN, name, office, and phone number. Question mark, why? Because phone is an optional. And now you define each element. Element SSN, each one is element. You say company is an element. Company consists of person and product. And then person is an element which has name, social security number, PC data. So now you represent all data. And then product, you say product is PID, name, description is an optional, and then PC data. PC data means parse character data. So when you define this, it becomes actually document type definition for the company. And then I can use this DTD, parse this DTD and check your XML whether it is a valid XML or not. So a very simple DTD again, you can see example of valid XML document based on DTD. Alright, so DTD, the content model, there is an element tag, and in the content model you have actually complex, it's a regular expression, text only parse character data, it can be empty, any means any, and you sometimes have asterisk means many, can be repeated combinations. These are actually regular expressions. You can see here element, then option means there's a question mark, and then you have cleany because it has actually many. So for each XML you can see for corresponding regular expression and the XML representation. So how do you query XML data? You have three options. You can use XPath. XPath is a technology which actually you can parse, you can actually search inside XML because you're looking for data in XML. How do you look for data in XML? You have to use this query, XPath or XQuery or XSLT, recursive traversal. So what happens, that's a simple data for queries. We have this XML file and we are looking for something. So the data model for XPath is like this. You can take a look at XPath in detail. XPaths, there are some expressions, so I can actually ask those expressions and find it easily. XPath, there are restricted clean closure, that's something we have. XPath, there are text nodes, and we can actually use XPath text node to do that. XPath, we can use wildcard also, and XPath, these are actually attribute nodes. We can actually use XPath to actually search in XML file. So these are actually more predicates of XPath, and I'll just skip some of them. XPath summary. So that's all for XML discussions, and I hope you really interestingly